I'm going to talk you through some examples and try to explain what I'm doing step by step as I'm doing it. So here we go. Let's look at the first problem on this page. Solve for x, and then we've got an equation to solve. So what does it mean to solve for x? It means find the value of x that makes this equation true. So what number could I substitute in for x so that when I consider minus x plus 4, I get 3. So we're trying to figure out what value of x would make this equation true. Okay, and the strategy we've learnt in topic 10 is to convert this formula first into a box diagram. So to convert it into a box diagram, we need to think about how this formula is built up from x. So if I might even draw this in to think about how we build up from x. Let's put a little circle around the x. So if we start off with x, what's the next step in building this formula? Well, the next step is minus x. And minus x, remember, minus x is just the same as negative 1x, which is just negative 1 times x. So minus x is just a short way of writing negative 1 times x. What's the next step in building up this formula? Well, then we want to add 4. So that's how our formula is built up. Let's mirror that process in a box diagram. So in the box diagram, we always start with an empty box. That's where we're going to end up with our answer for x. We want that to appear after we've backtracked in that box. So starting with x, building up our formula, the next thing that happened was we multiplied by negative 1. So let's write that in, and let's write a box for the result when we multiply by negative 1. And the next part of the formula is to add 4. So we'll write add 4, and we'll draw a box for what happens after we've added 4. And in fact, we know what happens after we add 4. At the very last step of the formula, we get 3. So when we take x, we multiply it by negative 1, and then we add 4, then the answer is 3. So that's our box diagram that corresponds to that formula. And now what we want to do is unpack that. We want to undo everything that was done to x to give us 3 so that we can work out what x was to begin with. So to undo this process, we want to backtrack. And one way to think about backtracking is we're undoing the operations, which means we have to do the opposite operation. So think about this box here. Let's work out what must have been in that box. So what would go in that box so that when we add 4 to it, we get 3? That's the question we're asking. So we want a number in this box here that when you add 4, you get 3. So you can think about this in terms of a number line. Where would I be in the number line if after I add 4, I get 3? Or you can think about this in terms of undoing the add 4, which means doing the opposite of adding 4, which is subtracting 4. So now if we go 3, subtract 4, well, that gives us negative 1. So at this point, we've worked out what number must have been in this box. We must have negative 1. And in fact, let's just check. If we go negative 1 and add 4, well, yes, we do get 3. Negative 1 plus 4 is 3. So we've worked out correctly what number goes in this box. Okay, now let's go back another step. We want to work out what number was in the first box so that when we multiplied it by negative 1, we got negative 1. That should be fairly straightforward. If we multiply something by negative 1 and we get negative 1, we must have started off with 1 in the first place. But the other way to think about it is to think about undoing this operation. So instead of timesing by negative 1, we want to divide by negative 1. That would be the opposite of multiplying by negative 1. So we're going to take what we've got in the second box, negative 1, and divide it by negative 1. So negative 1 divided by negative 1, and that is indeed 1. So when we backtrack from 3, going through step by step, filling in the boxes as we go, we get back to 1. So our answer is x equals 1. Now, check your box diagram first. So we're going to check by tracking forward. So start off at the beginning and work forwards and make sure that what goes in each boxes works out. So we've got 1 times -1. Yes, that is -1, so that means that that box is correct. And -1 plus 4, yes, that is 3. So we've checked that our box diagram works with the value 1 at the beginning. And then the other way to check that you've got the correct answer is to just substitute back into your original equation. So let's do that. Just get rid of some of the mess. So to check, let's substitute. So we're going to substitute. We've got minus x plus 4 equals 3. Substitute in 1 for x, so we get minus 1 plus 4 equals 3, and that checks out. So we have found the correct value for x. We've solved for x in this equation. Let's have a go at the second one. Let's create the box diagram first. So thinking about how this formula is built up, we could draw up little circles again. So we started with x. What's the next thing that happened when we were building up this formula? Well, it looks like this is the next thing we need to do. Subtract 1, then multiply by 3, then subtract 4, and at the end of that we get 5. So that should give us some ideas about how to draw our box diagram. So starting with x, subtract 1, and we'll get some intermediate value. Multiply by 3, get another box, subtract 4, and then in that final box we've got 5. So can you see that the box diagram really just tells you, if you were substituting in a number for x, what steps would you do? The first thing you would do is you would subtract 1, then you'd multiply that by 3, then you'd subtract 4 from that, and at the end of that process you're getting 5. Okay, so there's our box diagram for this equation. And once we've got our box diagram, we use our backtracking skills to work out what number we must have started with in order to end up with 5. So we started with some number, and when we did this to it, we subtracted 1, then multiplied by 3, then subtracted 4, we got 5. So let's go backwards and try to work out where we must have started. So we ended with 5, and the very last thing we did to our mystery number was we subtracted 4 from it. So what number did we have in here that when we subtracted 4, we got 5? We need to undo what was done. So instead of, so we subtracted 4 to get 5, so to get from 5 to back where we started, we're going to need to add 4. So let's add 4. So 5 plus 4, we get 9. And then just check by going forwards. 9 minus 4, yes, that is 5. 5 plus 4 equals 9. Okay, let's go back another step. So what number must we have in this box so that when we multiply it by 3, we get 9. So hopefully you can see that that has to be a 3. 3 times 3 is 9. If we had trickier numbers, you could backtrack by doing the opposite. So instead of multiplying by 3, we're going to divide by 3, and what we want is 9 divided by 3, which is indeed 3. Okay, so that's that box, and now final step, we want to work out what was in the first box, that when we subtract 1, we get 3. So some number minus 1 equals 3. Should be able to see what that answer is, but let's we can do instead of thinking about it, we could just do the opposite. So the opposite would be to add 1, so we want to go 3 and add 1, and we get 4. So let's check by tracking forward. 4 minus 1, yes, that's 3. 3 times 3, that's 9. 9 minus 4, that's 5. Okay, so we've backtracked successfully, and we end up with our answer of x equals 4. And let's check by substituting back into the original formula. So we've got 3 times x minus 1 minus 4 equals 5, and we're going to substitute in a value of 4 for x. So writing it down like this. BODMAS tells us to do the brackets first. So 3 3 minus 4 equals 5. Remember 3 with 3 in brackets is multiplication, so now we better do that first. 3 times 3 is 9 minus 4 equals 5. Hey, that checks out, so we've done it correctly. Okay, and now let's see a slightly more challenging question, just so that you can see the full scope of what we're doing. Again, let's start by working out how this formula is built up. So when you're working out how it's built up, think about how you would substitute. If you were substituting in a value for x, what would you do? You would have to multiply by 5, then add 1, then multiply by 3, then divide by 2, then subtract 2, and that would equal -8. So why don't we just try, we could just have a guess at an answer for this. We're looking for the value of x so that when we substitute it into this side, we end up with -8. Let's guess. Why don't we say, oh, maybe the answer's 1. Let's see what happens. So let's just try x equals 1. How do we substitute in to the formula? What's it going to look like? Well, 3, 5, and now instead of writing x, I'm going to write 1, but I'm going to put it in brackets to remind myself that there's a multiplication there. 2 minus 2. Okay, I'm going to try that and see if I get -8. Brackets first, so 3, and then within the brackets I've got a multiplication, so I better do that first. Now I had better do my brackets, so I've got 3 brackets 6, and what is this? 3 bracket 6 is the same as 3 times 6, which is 18 over 2 minus 2, and I've run out of space, but we'll just keep going. 18 over 2 is 18 divided by 2, which is 9 minus 2. So my answer is 7. So I know that 1 isn't going to be the correct answer, because what I want at the end of the day is to get -8. Okay, so that's just a little try, but also it helps us see how this formula is built up. So think about when we substituted just then, the first thing we did was we multiplied by 5. So we multiplied by 5, and then we added 1, and then we multiplied by 3, then we divided by 2, and then we subtracted 2. So that's the order that we carried out our operations. So that's the order of our box diagram. Okay, let me just clear the slides so that we can see what we're doing. And let's draw the box diagram now for this formula. What does it look like? Okay, so we're going to start with x, and here's what happens to x to build up the formula. Well, we multiply by 5, and then we get a value. Then we add 1, and that gives us a new value. Then we multiply by 3, and that gives us a new value. Then we divide by 2, and then we subtract 2, and at the end of that whole big long process we get -8. Okay, let's backtrack. So what number? So starting at the end, we've got -8 at the end. What was in the previous box? Whatever it was, when we subtracted 2, we got -8. So to undo, we want to add 2. -8 add 2 is -6. And just check by going forwards. -6 subtract 2, yes, that's -8. Let's go back the next step. Some number divided by 2 gives us -6. What number would that be? Well, let's undo the divided by 2 by multiplying. So -6 times 2, that's -12. And just do a check by going forwards. -12 divided by 2 is -6. Let's go back the next step. What did we have in the previous box? So that we multiply it by 3 and get -12. That's the same as saying what's -12 divided by 3, and the answer is -4. Let's go back the next step. Or let's check first. -4 times 3 is -12, so we've done that correctly. Go back one more step. We need a number that when you add 1, you get -4. So that's the same as saying -4 minus 1, which is -5. And check, -5 plus 1 does equal -4. So all good so far. Final step, we want to know what did we start with, so that when we multiply by 5, we got -5. And that's the same as saying let's undo the multiplied by 5. So -5 divided by 5 is -1. So our answer is x equals -1. And I'll leave you to check that that actually works in the formula. So check by substituting x equals -1 into this formula up here, and you should get -8.